We have all heard about evaporation at some point. What exactly is it? Evaporation is the process of a liquid substance transforming to its gaseous state when it receives external stimulation, generally in the form of heat. Heat energy is absorbed by liquid molecules, some of which break away from the linkages binding them to one another and are released in the form of vapor, or in other words, the liquid evaporates. A common example is the drying of damp clothes hung out in the sun. Damp clothes consist of water molecules bonded loosely with the cloth fibers. Energy from the sun and the wind flow through these clothes, carrying with them some of the water molecules, eventually drying the clothes. Simply put, clothes in the open dry due to evaporation. That was evaporation. What about evaporative cooling? When air passes over a stream of water, water vapor is added into air, lowering the air temperature. The energy needed for evaporation is taken from air, and the loss of energy is reflected as a reduction in the air temperature. This phenomenon is called evaporative cooling. A very common example is one we all experience on a daily basis: perspiration. As air passes over the skin, evaporation takes place and a cooling effect is felt. This is because the sweat takes away some of the body heat during evaporation. Now that we know what evaporative cooling is, let's look at the two types: direct evaporative cooling and indirect evaporative cooling. In direct evaporative cooling, warm air from outside is pulled through moist pads where it is cooled due to evaporation. The cool air with added moisture is then drawn to the space requiring cooling using a blower. The second type is indirect evaporative cooling. Here, we use a sensible heat exchanger as the medium. It consists of alternate panels allowing wet air streams and dry air streams. Water is allowed to drip on the heat exchanger into the panels allocated for wet air streams. The fans are switched on, and as warm air passes over the wet surface of the heat exchanger, water on it evaporates and the material of the heat exchanger is cooled. Air is then passed through the dry panels of the heat exchanger, where it is cooled by virtue of its interaction with the cool surface. This cooled air, without any added moisture, is let out at the other end. In indirect direct evaporative cooling, air is cooled first with indirect evaporative cooling and then cooled further with direct evaporative cooling. Psychrometry is the study of moist air, and psychrometric charts are the tools used to study them. Let's have a look at the elements of this chart and use them as a reference to understand evaporative cooling. Dry bulb temperature is represented on the x-axis and increases as we move from left to right. Wet bulb temperature lines are inclined and straight. They increase from left to right along the highlighted curve. Enthalpy lines are also inclined and straight and increase in the direction of the highlighted curve. Specific humidity is represented on the y-axis, increasing as we go upwards on the chart. Constant relative humidity lines are curved and increase from right to left. So moving towards the right or left on the chart parallel to the x-axis would be sensible heating or sensible cooling, where the dry bulb temperature changes without a change in the moisture content of air. Moving parallel to the y-axis would cause humidification or dehumidification, that is, changes in humidity levels of air without changing the dry bulb temperature of air. Moving perpendicular to the wet bulb temperature lines would cause a combination of cooling and dehumidification or heating and humidification. Moving along the wet bulb temperature line downwards would be heating and dehumidification, whereas upwards would be cooling and humidification, which is what happens during evaporative cooling. The basic principle of indirect direct evaporative cooling can be understood using a psychrometric chart. Indirect direct evaporative cooling involves treating warm air first with a sensible heat exchanger. This is the first stage, or the indirect stage, where sensible cooling takes place and we see a reduction in the dry bulb temperature without any change in humidity. In the second stage, or the direct stage, the air is cooled and humidified, as can be seen in the psychrometric chart. The dry bulb temperature is reduced further and
So this is the Coolerado indirect evaporative cooler, and this extends our Climate Wizard range down to smaller capacities. This is unique. This contains our HMX core, which is patented and which achieves far more cooling than any other indirect evaporative cooler on the market. We can cool to below the wet bulb temperature of the air using this, which is impossible with any other cooler that exists.
How does the Coolerado system do it? check it out. The heart of the system is the heat mass exchanger, or HMX, made up of thin plastic sheets they call plates.
This is kind of the insides of that heat transfer unit.
And this plate is a solid piece of plastic on one side. That's the heat transfer surface. It's polypropylene. On the other side is a polypropylene fiber, and that wicks the water.
The specially made plates contain channels that draw the moisture. At the Colorado factory, the sheets of polypropylene are cut, stacked, and pressed.
So this is it. This is what it looks like when they're all stacked together, huh?
80 plates go into make one heat and mass exchanger.
Next, they frame them up. With an inlet for water added, it's ready to go.
There's 5 heat and mass exchangers in here that are going in a modular fashion. They stack up 5 of them. You got your water distribution system, your fan.
Yeah, that's a cool looking fan.
Amazingly, that fan is one of just 2 moving parts in.
A portion of the hot water is diverted into CSIRO's new solar air conditioning unit, which is divided into 2 compartments. The hot water enters a heat exchanger in the first compartment of the unit. Similar to a car radiator, the heat exchanger uses the hot water to heat outside air that has been drawn into the first compartment through the vent. At the same time, outside air is also being drawn into the second compartment into a desiccant wheel. The desiccant wheel is the most critical part of the system. It is used to dry out the air before it goes into the house. Slowly turning, the desiccant material in the wheel continuously absorbs moisture in the second compartment. And then the absorbent material dries out in the first compartment. The desiccant material is dried out using the hot dry air generated by the heat exchanger. This air is then exhausted outside the home. The dry air from the desiccant wheel flows through an indirect evaporative cooler, which creates a stream of cool, dry air. This cool, dry air is then fed into the home in order to cool down the rooms.